Jai Hind all of you. So welcome back to the chemistry class. In last today we discuss about that difference between the solid, liquid and gases, and also we talk about that different scale of the temperature. So let's start our class. So first of all, when we talk about the already we have read about the different type of solids, different type of states. First one is the solids, second one is the liquid, third one is the gas. Now if we differentiate their characteristics, that time we can understand that if I talk about, if obviously we'll see at first the properties. If I talk about the properties, then you can immediately tell that solid has a definite shape, whereas a liquid and gases doesn't have the definite shape. They take the shape of the container. When I talk about the volume, so solid and liquid both have the definite or fixed volume, but whereas the gases doesn't have that where the fixed volume. Now third point, if I talk about, the third point is compressibility. The solids are liquid generally non-compressible or incompressible you can say, but when I talk about the gases is highly compressible. In last class when we talk about the properties of gas, that time we talk about we tell that it is a highly compressible. If I talk about the rigidity, so everyone knows that solids is a highly rigid because its intermolecular force is a very strong and its density is also very high and it is a closely packed. So here the 4 point is there, all are stronger for rigidity is for solid, density is high for solid, the closely packed for solid, and intermolecular force for solid is a high, whereas for gases these are very low. If I talk about the rigidity, gas are not rigid, their density is very low, they are highly loosely packed, that is why they have the large intermolecular spaces, and the intermolecular force is very negligible in case of gases. Now the very important point, that kinetic energy of the particle, as you know that the diffusion is not possible in the solid, that is why the kinetic energy of particle is a very less here, whereas for gaseous molecule, as gas diffuses faster, so that their kinetic energy is also very large. So these are the point we can use to differentiate different states of matter. Now we are moving to next slides, where we can see that if one activity we are doing regarding the study of the compressibility of solid, liquid, gas, obviously what we have to take, we have to take 3 syringe, and for every syringe we have to use the rubber cork to close their that open nozzle, okay, to close their nozzle. Now what we will do, in one syringe we are taking the chalk powder, okay, and second one we are taking water, and third one it is a vacuum, you can say it is a just normal, say that normal syringe. Now when we are pushing that piston, what do you observe, that you cannot compress that first one where chalk is represent, and the water is also you can press, but it is also very difficult to compress, but for air you can easily compress this one. So from the experiment, from the activity, what you will learn, you will learn that the gas can easily compress, whereas solid is not compressible. Okay, so this is the very important activity which you can do in your home also. Now we are moving to the next part, that how can you explain this phenomena. Obviously activity we have seen, now what is the reason behind the activity, that what is the reason or what is the explanation. So first of all, that if I talk about the solid, liquid and gas, you can see in the solid it is a highly packed, their intermolecular forces are very strong, intermolecular space is very small here, that is why they cannot move, their molecular arrangement is a fixed, it is a packed like structure. So when you are giving pressure, it is not compressed anymore, but when you look at the liquid and gases, you can check here that in liquid intermolecular force is not so much stronger than like solid, and not so much smaller like gases. It has the some amount of intermolecular forces, or some intermolecular spaces is also there, so it is a little bit highly compressible. Now if I talk about the gaseous molecule, so here you can see that gaseous molecule are highly compressible. Why they are highly compressible? Because the intermolecular forces are very less here and intermolecular spaces are very large. Obviously from the image you can understand that how much space is there and what is the amount of the forces is there. So we can easily compress the gas. Okay, the next point is that if I have the two question, here the two question is there. First one question is that water, sugar and oxygen is given and we have to arrange them according to the increasing order of force of attraction. So oxygen, water, sugar, oxygen, water, sugar. Obviously as sugar is a solid, so it is a maximum force of attraction, and as oxygen is a gas, so it has a very less force of attractions. Now question number 2a, water at room temperature is a liquid. Why? What is the reason? So obviously why water at a room temperature is liquid? Its intermolecular forces are less and intermolecular spaces is more. That is why the molecule of water can interchange their space and hence water is a liquid instead at room temperature. Next question, at room temperature iron alumina is solid. Obviously iron alumina is solid. Why? Because it is a rigid structure, its intermolecular forces are large and also it has a minimum amount of kinetic energy, and that is why it is a solid at room temperature. So whenever the question is like this, that the water is a liquid, iron is a solid, that time you have to give the answer on the basis of these properties, this point property. If you are just giving the properties, you will get complete answers. Okay, so that is the point. Now we are moving back to our today's topic, that is the different unit of temperature, different scale of temperature. Generally we are using three temperature scale. Number one is a degree Celsius, number two is Fahrenheit scale, and number three is Kelvin scale. Sorry. So we are starting from the Fahrenheit scale. So what we are starting? We are starting from the Fahrenheit scale. The Fahrenheit scale was first introduced by Daniel Fahrenheit and it is denoted as a degree Fahrenheit symbol. One very important point is that when I are talking about that what is the freezing point of water in the Fahrenheit scale, it is a 32 degree Fahrenheit. It is a 32 degree Fahrenheit. And if I talk about that what is the boiling point of water, then it is at 212 degree Fahrenheit. 212 degree Fahrenheit. It is a boiling point of water. Boiling point of water. And it is a freezing point of water. So that is a very important. So you have to remember that, as we know about the water is naturally present in solid room, liquid and gaseous state. So we have to know that which temperature it will be freeze and which temperature it will be evaporate. So in the Fahrenheit scale, the temperature at which water freezes is 32 degree Fahrenheit and at which it will evaporate it is the 212 Fahrenheit. So I hope you understand the Fahrenheit unit. Now we are going to the degree Celsius scale, which is a very vastly used in common life. We are generally using the degree Celsius scale, or it is called the degree centigrade scale as well. It is represented degree Celsius like this. Okay, so this scale has been introduced by Andre Celsius. So obviously from the name we are talking it is a Celsius scale. Now in the Celsius scale, when you talk about that freezing point of water and the boiling point of the water, that is a very important, and we all know about that 0 degree centigrade is the freezing point of water and 100 degree centigrade is the boiling point of water. Now this is the another scale of temperature. Now the next, and which is the most important scale, that is the Kelvin scale. Kelvin is the SI unit of temperature and it was introduced by William Thomson Kelvin. So you have to remember that what is the SI unit of temperature? What is the SI unit of temperature? SI unit is called Kelvin temperature. SI unit is Kelvin temperature. So that is a very important. SI unit is not degree centigrade or degree Fahrenheit. It is a Kelvin. Now, one very important point, nowadays we are generally following the degree Celsius scale. We are following the Kelvin scale because that is the SI unit. Now, in last two cases I have told you that about the freezing point and the boiling point of the water. So again if I talk about that Kelvin scale, so in the Kelvin scale 273 Kelvin is the freezing or melting point of the water, whereas the 373 Kelvin is the boiling point of the water. So this part you have to understand. Now automatically the question will come, what is the conversion? How can we convert degree centigrade to degree Fahrenheit, or how can you convert degree centigrade to Kelvin scale? And for this conversion, we have to remember this certain formula, that Celsius to Fahrenheit, when I talk about the degree Fahrenheit equals to degree centigrade into 9 by 5 plus 32. And similarly, Celsius to Kelvin, how can we talk? That Kelvin equals to degree centigrade to plus 273. We have to add 273. Okay, so this is the conversion formula that you have to remember. Now we are moving to the next part. Suppose one example we are giving. Here already one example has been given, that how can you convert 1 degree centigrade to Kelvin scale. So already we know the formula, that if the degree centigrade temperature is given, if you add 273 degree with that degree centigrade scale, then automatically you will get that the temperature in the Kelvin scale. So if I talk about the 0 degree centigrade, you just add 273 with the 0 and you will get the temperature in the Kelvin scale, 273 Kelvin. Similarly, if I talk about the 100 degree centigrade, you just add 273 with the 100 and you will get 373 Kelvin. So these part are present. Now next one we are talking about, suppose I have one example. I am talking about that room temp, we are generally talking about the room temperature 25 degree centigrade. So 25 degree centigrade if I talk about, then what will happen? What is the temperature in Kelvin? So what you will do, you just add 25 plus 273 and you will get 298 Kelvin. So it is a very important that you have to know the conversion formula. Now suppose I am asking you that, okay, I have the 25 degree centigrade, can you convert it into the degree Fahrenheit? So already you know the formula. Degree Fahrenheit formula is 9 by 5 multiply that degree centigrade temperature, that is the 25 degree centigrade, plus 32. So what we will get? That 5 was a 5, that 87 degree Fahrenheit. 87 degree Fahrenheit. So easily you can get this type of questions and you can easily solve this. One few more example is given there. Before moving to that one, I am just showing one temperature scale. Here 3 thermometer is given in different scale, and you can see in every cases boiling point of water and the freezing point of water has been mentioned, and you can check that when we talk about the 0 degree centigrade, which is equivalent to 32 degree Fahrenheit and 273 Kelvin. Similarly, if I talk about the boiling point of the water, it is 100 degree centigrade and it is the 212 Fahrenheit and it is a 373 Kelvin temperature. Now absolute 0 degree temperature, what is known as absolute 0? You know very well that when you talk about the 0 Kelvin, as the temperature everything freezes, that is called the absolute 0 temperature. So absolute temperature means the 0 Kelvin temperature. So already you are getting that if it is a 0 Kelvin, so the temperature will be in its centigrade scale, it will be minus 273 degree centigrade, and in Fahrenheit scale it will be minus 460 degree Fahrenheit. Now remember that Kelvin is in the Kelvin scale, temperature is the minimum temperature is possible 0 Kelvin. If in the Kelvin scale temperature never be negative. In Kelvin scale temperature never be negative. So this part you have to remember. Next one, 2 example is given here, that convert the following temperature in the centigrade. Kelvin scale it is been given there and we have to convert into the Celsius scale. So if 300 Kelvin is there, so you can, what you will do, you just use the formula Kelvin equals to degree centigrade plus 273. So already in Kelvin temperature it is been given. So what I will do, in the Kelvin place we are adding, we just put the place 300 and we will get that 27 degree centigrade. Similarly, if I talk about the 573 Kelvin, you just subtract 573 with to the 273 and you will get the 300 degree centigrade. Next one, if the temperature is given in the degree centigrade and we are telling you to have to convert into the Kelvin scale, you can easily do by adding 273. Suppose 25 degree centigrade is there, you just add 273, you will get 298 Kelvin. And if I have the temperature 373, you just add 373 with the 273, you will get the 646 Kelvin. So like this you can easily get any temperature, you can easily convert from 1 Celsius to Fahrenheit or Celsius to Kelvin easily. So I hope you understand this topic. In next class, we'll discuss many more things. And now we are concluding the class. Again, we'll meet. Till then, goodbye. Jai Hind.